The excess code is a way to store negative and positive binary numbers. Normally only positive binary numbers can be stored in a memory. We consider the coding in the case of a 4-bit memory, as this can be represented simply and clearly. The first line shows all 16 memory entries. The second line indicates how this memory entry is interpreted. By default, the entries are interpreted as binary numbers from 0 to 15. But sometimes you want to store negative numbers as well as positive ones. To achieve this, there are several possibilities. The excess code is one of them. Thereby the value range is shifted by a certain number of digits, so that negative numbers can also be represented. With the code excess 0, the value range is shifted by 0 digits. This corresponds to no shift and the value range remains 0 to 15. In the table, you can now see the designation of the coding, by how many places the value range is shifted, and the interpretation for each memory value. The 0 in the name of the coding says that the value range is shifted by 0 places. Of course, it makes more sense if the value range is actually shifted. With the coding excess 1, for example, the value range is shifted by 1 digit. With this coding, however, only a negative number can be represented. In order to be able to represent more negative numbers, a larger shift must be selected. In the table you can see 4 other examples for codings, with which several negative numbers can be represented. These are, for example, the codes XS2, XS3 and XS4, and the coding XS8. As you can see, the larger the shift, the more negative numbers can be represented. Now we clarify the question of how to proceed if you want to store a number coded. To store a number with excess code, one simply adds it with the shift. After that, the result in the binary system is written into the memory. For example, if we want to store the number -7 with the code XS8, we calculate -7 plus 8 is equal to 1. We write the 1 in the binary system as 0001. Now we can enter this sequence of numbers into the memory. We can also check the calculation using the table. For this we go to the row XS8 and to the column -7. The memory entry is at the top of the column. In practice, it is often useful to be able to store the same number of negative and positive numbers. For example, when we want to store the result of a measurement, and this result is in the range around 0. For these cases the balanced excess code is used. Here, half of the stored values are interpreted as positive numbers and the other half as negative numbers or 0. To calculate the appropriate shift, use the formula 2 to the power of n by 2, where n is the number of bits. Let's use a memory with 4 bits as an example. We put the 4 into the formula and get a shift of 8 as result. So for a 4-bit memory, the balanced excess code is XS8. We will again look at the corresponding line from the table we already know. We can see that 1/2 of the memory entries is used for the negative numbers, and the other half for the positive numbers and 0. So we only have to look at the first bit in the memory to know which sign a number has. The most significant bit gives information about the sign. With a 0 the number is negative, and with a 1 it is 0 or positive. This is helpful in case the sign of a number is needed to be checked quickly.
Subscribe to our channel and share, like and comment our videos.